Well, we have come to the end of this class. We've hit our limit, and it's only appropriate that our last lessons lead up to limits. For those of you moving on to calculus or you're going to take it in college, hopefully this will help you a little bit more and be prepared. So this first video is just all about the introduction to what a limit is, and it's used a lot in what's known as tangent problems and area problems in calculus. We will get to the tangent problem. We probably will not get to area. Okay, so here is just our formal definition of a limit. So it says f of x, and it's just a function, and it becomes arbitrarily really close to a unique number, and we're going to just call that unique number L, as x approaches c from either side. And the limit of f of x as it approaches c is L. So basically what this means is it can be written like this. So we're going to call limits, we're going to say it's LIM for limit, and as x approaches c. Okay, and we want to do it from both sides, so we're going to notice sometimes you might have Googled what a limit is, and you'll see like a plus or a minus up there. That has to do with coming to one side or another. We'll get to that in another video. But again, as this approaches, so whatever your function is of f of x, it's going to equal L. Okay, that's basically what this is saying. Okay, so right now, even though you can't see me, what I want you to think about is this. If you were to hold up your fingers, right? And so here's finger 1 and finger 2, right? I'm a great drawer with fingers, okay? As your fingers get closer and closer to this line, right, are your fingers going to touch? And if they touch, then we know that the limit exists, because from the left side and from the right side, it's going to hit 1 point, right? We're going to get really close to this point. Maybe we actually never get to that point, but we get really close. If your fingers never touch, right, so maybe this finger is actually up here, then it's not going to exist. So that is kind of like the basics of limits, right? So here's a picture of a graph that hopefully will help make it a little bit easier for you. So again, what is happening is from one side of your graph, right, the right side of your graph, and then from your left side, I'm approaching a number, right? I'm approaching 2. So as x approaches 2, what do we notice is the output, right? As I get closer and closer, it's 6 up here, then it's 5 here, then it's probably, 4 point something, 4.0001 maybe on that side. Here it's, 2, and then 2.5, and then 3, and then 3.99999. And so what we're noticing is it's getting closer and closer to 4. So our fingers are touching, right? So so to speak, right? Now, we don't actually ever get to that number, which we'll talk about later. Sometimes we actually get to the number, sometimes we don't. Okay, an example of something that would not touch. So say I was approaching, let's say I was approaching 1 on this graph. So as I come from the left-hand side, my output ends up being, so from the left-hand side, I get -1, and then from the right-hand side, I'm getting 1. And so notice that my fingers are never going to touch, right? So there's kind of an opposite space, okay? And it looks so happens that the answer was 2 on this problem. Like there's a dot there. Again, that doesn't really matter. So again, just be thinking about when you're visually looking at your graph, kind of what is happening to your graphs, okay? And it doesn't have to be this number 1. We can have it approach any value. Okay, here again, here's another graph. So notice it says, what is the limit of the function as x approaches x approaches 4. So again, we would say the limit as x approaches 4 of f of x. And so notice as I'm approaching 4, which is right here. Okay, so as I'm approaching it from the left-hand side, it looks like my output is going to be 2. And I don't care about this part. I care really just about this part. So as I approach it from this side, right, I'm coming down, and it also looks like my output's going to be 2. So I would say 2 as that answer. So again, we can always use our graphs to help us, okay? But we can also use our table, okay? Now, there are three types of graphs. Before we get to our table, there are three types of graphs where limits are not going to exist. So I want to touch about that first, okay? So the limit of f of x as x approaches, so I drew the little arrow of c, it does not exist if any of the following conditions are true, right? So as f of x approaches a different number from the right-hand side of c than it approaches from the left-hand side, right? So this would be an example for number 1. Okay, so as I go from left-hand side, I'm approaching, say this number is 2, and then from the right-hand side, right, this number is 4. So again, 2 is not equal to 4. So I know that this does not exist. That limit does not exist as x approaches some arbitrary number. All right, for the second one, it says f of x increases or decreases without bound, right? So this graph, it says it's a blow up, right? So notice that as I'm approaching some number, my graph is going up and up and up and up and up, approaching infinity. Same thing on this side, infinity. I actually have no idea what number it is approaching. And so that's what that means, is it approaches it without bound. So either think of this graph going upward or think of it kind of going downward. Okay, so this would be a does not exist. And then number 3, oh, I just realized I spelled that wrong. That should be an O. Your f of x oscillates, so basically just goes back and forth between two fixed points. And so we can kind of sometimes see this with trig, not all the time, but trig is usually one of the bigger ones. Does not mean trig means that you're always going to be, does not exist. Just some trig tends to not exist. So again, it goes back and forth. So maybe your answer goes back and forth between 1 and -1 as our graph gets closer and closer to that, to some sort of number. Okay, so these are three ones that are not going to exist. Okay, but let's see how you would look at a table to kind of figure this out, right? So estimating a limit numerically. Okay, so here's our first example. So the limit as x approaches 2 of 3x minus 2. Okay, so when I'm approaching this graph, it's a line. Okay, what I want to do is I want to make a table of points, right? So x and f of x, and basically what I want to do is I want to leave this one alone. I'll put a question mark here. Now later on we're going to see that if I plug in the number 2, like I'm going to get an answer. So I want to plug in some numbers that are close to the number 2. So I might plug in, 1.9. That seems like a good number. I also, and notice I'm leaving a little bit of space, I might plug in 2.1. So let me pull up my calculator. You can always use Desmos. So I'm going to plug in 1.9. I'm going to see what happens. So 3 times 1.9 minus 2, I get about 3.7. So 3.7. And then 2.1, so 3 times 2.1, and then minus 2 is 4.3. Okay, so these numbers don't really tell me how close I'm going to get. So I want to try to get closer. So how about 1.99? And then for this one, I'm going to say 2.01. So 1.99 times 3 minus 2, 3.97. 3.97. And then 2.01 times 3 minus 2, 4.03. So 4.03. Okay, so this one is, I can see that's getting closer to number 4. I want to keep going. So 1.999, 2.001. Again, the closer I get to the number 2 without actually using that, I will see what my limit is. So 1.999 times 3 minus 2. And notice I'm going to get 3.997. Excellent. And then 2.001 times 3 minus 2. So it should be 4.003. So it's safe to say, right, I could get even closer, that this number 2, as x approaches x approaches 2, I'm pretty sure that my limit is going to be the number 4. Okay? Now, what I could do is I could do direct substitution. What would happen if I plugged in 2? So 3 times 2 minus 2. So 3 times 2 is 6. 6 minus 2 gives me 4. So basically what this means is there's an actual point when I plug in the number 2, I actually get 4, right? But this is my limit, okay? And I want to make sure that something is very clear here, okay? Direct substitution does not always necessarily work. And I'm going to bring it back to this picture. Okay, so say this picture, I want to know what happens when x is equal to the number 1. When x is equal to 1, this is what my answer is, right? 2. I would get, y slash f of x is equal to 2. But on this problem, as I approach 1 from the left-hand side and I approach 1 from the right-hand side, notice that my numbers aren't going to meet. And so I'm not going to actually get an answer. So this limit as x approaches 1 on this problem does not exist. Even though, say I plugged in a number 2, I'm able to get 2 as an output, right? This does not exist. Okay, so it's very important that we remember direct substitution sometimes can help us, but it is important to look at that table because sometimes it doesn't necessarily give us that full answer. And the other question is what happens if direct substitution doesn't work? So what happens if I approach this problem? So I say the limit as x approaches 0 of, I don't know why I wrote 0 here, as x, and then the radical of x plus 1, and then minus 1. So if I was to do direct substitution at this point, I plug in a 0 everywhere I see an x. I would get 0 over 0 plus 1 minus 1. This gives me 0 over the radical of 1 minus 1, which is 0 over 1 minus 1, which gives me 0 over 0. That doesn't help me. So I have to come back to this lovely table. Okay, so let's come back to our table. I'm going to do my table a little bit differently this time. So again, x and y, I'm going to put 0 in the middle. And I already know if I plugged in 0, I'm not going to get an answer. Okay, so maybe I want to start with 0.01, and maybe I'm going to have a negative 0.01. So let's come over here. Okay, and you can always use your table to help. You can always plug it in to the value. So let's say 0.01 divided by, and then the radical of, oops, I didn't mean to write the square root. Let me just clear all this. So 0.01 divided by, okay, the radical of 0.01 plus 1 minus 1. Close parentheses. And I'm going to get 2.004. So 2.004. Excellent. I'm going to go ahead and I'm going to insert a negative. And I'm going to insert a negative here. And I'm going to get 1.99. So 1.99. And I can continue to do this, right? So negative 0.001 and 0.001, 0.0001, 0.0001, but making it negative. What you're going to see is these numbers are just going to get closer and closer to the number 2. Okay, so go ahead and plug these in on your own and see kind of what's happening with our table. But for this problem, right, our answer, as we get closer and closer, it will be the number 2. But notice that here we weren't able to plug in some values to get those numbers. Okay. Now I want you to try a couple problems on your own. So I want you to try this one. So the limit as x approaches 3 of 5x minus 3, and then try this one. The limit as x approaches 0, x plus 9 minus 3, and see what you get for both of these limits, right? The answers will be found on the next video.